But it will still, and it will still give you kind of real-time data.
Hello, you hear me? Yeah. Okay, my name is Takemura. I'm very honored to be here, and I'm very much impressed by the enthusiastic support and the great hospitality of the museum staff here. So first, let me express my deepest gratitude to Mr. Mogridge and all the staff of the Cooper-Hewitt Museum. And I also would like to express my gratitude to Anna, ANA Cargo, for bringing the globe from Tokyo to Cooper-Hewitt. Okay, let me talk about my globe. More than 2,000 years ago, the Greek philosophers, ancient Greek philosophers and scientists were conceiving the Earth as a globe already. Aristotle wrote much about it, and Eratosthenes, the director of the first museum in the human history called the Museum of Alexandria, actually measured the size or scale of the globe, and using the knowledge of the geometry, as it literally means the measurement of the Earth. And nowadays, at least in these 50 years, we acquired the viewpoint or perspective to see the whole globe from space. And thanks to the space expedition, we came to understand the rareness and preciousness of our planet in the context of the universe. Maybe we are the first generation who came to understand the exceptional beauty and dynamism of our planet, exceptionally convenient truths of our planet, such as the existence of liquid water or moderate greenhouse effect, or the existence of the ozone layer, abundance of the solar energy. And yet, it is a pity that even now in this 21st century, the children, school children, are still learning geography and geology and even about the environment, global environment, using the two-dimensional maps invented around 16 centuries, or using the dead static globe without expressing any beauty and dynamism of our planet. So this is the basic motivation, a reason why we created this kind of things. Another thing is that I always feel something is missing in our information environment. Our economy is totally globalized, but our perception or our consciousness is confined in the local areas. And actually we eat every day, we eat globe, the whole globe, or we consume the whole globe. And yet we never think of where does the food or something is coming from, or we never think of the impact of our lifestyle on the opposite side of the globe. And lots of breaking news is conveyed, delivered to you, but no information about the daily life which is being conducted in every area of the world is not necessarily conveyed to you. So we are lacking something very important in our information environment. It's a lack of the information design, I think. And we need something like a real global information system, information design. So that is why the second reason I created this kind of things. So let me introduce you some vital functions of this globe. It's basically it's interactive digital globe. As you see, I'm spinning. You just put pressure in the direction you want to spin, and but this is interactive not only in the sense that you can spin it, but also you can detect specific areas using the magnifying pointer like this. It's a magnifying pointer, so you can scan the surface of our planet. So it's a view from the space shuttle, and if you move on to the Arabian desert, you can see the surface of the desert like this. And this is basically real-time globe. It represents the real-time present situation of our planet. For example, if I put day-night terminator, it's a real-time, so you can see the veil of the night is already on over the United States, and at the opposite side of the globe, the people in Beijing is now greeting sunrise. And if you overlay the real-time cloud data, this globe is downloading every 1 hour the latest cloud data. And now it's showing you the cloud data in the form of animation over the last 4 days. So at the last part of the animation, when it stops, it represents the real-time cloud distribution. I'll replay the cloud movement over the last 4 days. We had a stormy weather the day before yesterday and yesterday. And you can see here the stormy clouds moving around over the New York. And now it's the almost a real-time cloud distribution. And now you're enjoying the fine weather over New York, but you can see the some stormy things in the Indian Ocean or other areas of the globe. And you can get some real-time sound actually using this stethoscope. It's a magnifying pointer, but it can be used as a stethoscope. For example, if you zoom in on Tokyo, please note that this is not a pre-recorded sound. It's a real-time sound of Tokyo. It's around 9 o'clock, 9 a.m. in the morning. So you may understand I'm so jet-lagged, you know. But we are connected to the Tokyo right now, to the one of the very famous spring pond in Tokyo, in Tokyo University. And you can listen to the, you can hear the bird's voice, and maybe in 1 or 2 hours we will hear the voices of children playing around the pond. And if you move on to Kyoto, the internet connected microphone is installed also in Kyoto Temple, 70-year-old Buddhist temple in Kyoto. And you're listening to the real-time sound of the water drip in Kyoto. And there's another installed microphone in San Francisco. May I have some comment on this sound?
Yeah, well, our office is in a pier in San Francisco, and so when Takemura-san asked us if we would participate in this, we were thrilled to record the water, because particularly as storm is about to come in San Francisco, you get these huge waves that lap against the stones, and you get these very noisy splashings. But then if you have a calm summer day, it's actually very gentle. So we dug a big hole in the pier. It has redwood planks which are this thick. And we drilled a big hole and then put this microphone down underneath the pier so that it's listening to the water underneath the pier. And our meetings room, where we have our client meetings, is just on the edge where the rocks are sort of finishing. So you hear the waves crashing against the rocks as well as the water of the pier itself.
Thank you very much. Maybe later on I will go back to Tokyo, maybe to listen to the voice of children. But now I will demonstrate some other aspect of our planet. This is the ocean currents flowing along the westerlies. This is Gulf Current, which is the conveying a vast amount of heat from Caribbean Sea up to the North Europe, which makes the weather or climate in Europe very mild and far warmer than it's expected from the its latitude. And if you put the Great Ocean Belt Conveyor, you can see the great circulation all over the global oceans. And you can see the serpentine ocean currents by the sea surface temperatures. It's a black currents. Also, I can show you some geographic data like the seismic data. And it's a seismic events shown in the animation, and you can see not many seismic events are seen in the eastern area of United States, but the California, you can see these earthquakes. So if I show you the accumulation of the seismic data over the last 20 years, it will be like this. So you can see the ring of fire. And can you find Japanese archipelago? It's right on the tectonic borderlines, so you can see how vulnerable our country is. And of course, the California had many seismic events, but the magnitude is quite different. Especially the big earthquakes are very often happening in the western part of Pacific. And so Japanese archipelago is a kind of the floating boat, floating and always fluctuating on the fluid mantle movement. And we have to remember that we are living on this kind of the island. And also the Sumatra island is very vulnerable to the earthquake. And I will show you the tsunami. Only 2 or 3 hours it reaches Sri Lanka, and if you zoom in on Sri Lanka using a magnifying pointer, you can see the image of the disaster caused by tsunami. And these photos are sent through the internet from the NGOs in Sri Lanka right after the events. So this globe can represent the real-time data like the cloud movement or some other things, and also these kind of local information can be represented, sent and represented through the internet. So in this way, we can get the detailed information about what is going on over the planet, and by installing these kind of things, the internet microphones, you can feel connected to the various areas on the planet in real time. And let me mention the size or the scale of this globe, tangible Earth. This is the 10 million to 1 scale of the real Earth. In this scale, it's one of the vital part of the information design of this globe, because in this scale, everything becomes more understandable. For example, the cloud is swirling inside the thin layer of the air, the so-called the troposphere. The 90% of the air is concentrated at the lowest layer of the atmosphere, called troposphere. So how thick is the troposphere? In real life, the troposphere has thickness like the 10,000 meters. How much? 35,000 feet or something? Yeah.
33,000.
Okay. So anyway, it seems very thick, but in this scale, the 10,000 meters thickness becomes only 1 millimeter. So even children can see how fragile our layer of the air is. So the jet flies only 1 millimeter above this globe. And speaking of the space shuttle, as I show you the view from the space shuttle, how high the space shuttle flies. Maybe many people think the space shuttle is flying around here or around here, but actually it's in real life it's flying about 250 100 kilometers above the Earth, so it becomes only 2 or 3 centimeters above the globe. So the space shuttle is moving like this, only 2 or 3 centimeters above. But speaking of the moon, in real life, the moon is floating about 380,000 kilometers away from the Earth. But in this scale, it can be imagined, the moon can be imagined as the basketball, which is floating about 38 meters away from this globe. So you can imagine the Captain Armstrong went all the way to the moon. And so you can imagine how far is the moon compared to the space shuttle. So I'm not a scientist, actually. I'm basically an anthropologist, and I have traveled all around the world. I went all the continents except the Antarctic continent. And but I wanted to understand, I wanted to recognize the whole structure of our planet, and also I wanted to know what is really going on our planet. So that is the some essential aspect in my motivation to create this kind of things. But I wanted to understand more about the structure. Then it was necessary for me to make the globe in this scale to make the scientific knowledge more understandable. And now, as I show you the thin layer of the air, but what is impressive is that every miracle of our living planet is happening in this thin layer of the 1 millimeters. I will show you some biodiversity related content. It's a Siberia. And if you look at the movement of the migratory bird, you can see the bird is migrating south, escaping from the harsh winter approaching in Siberia. And if you zoom in on the nesting site, you can see the beautiful wetlands. And if you zoom in on the nesting site, you can get the image of the baby bird. This baby bird, the researcher attached the small GPS transmitter on this baby birds, and this is a trace of this baby birds flying south, escaping from the harsh winter of the Siberia. And another example is humpback whale. You can see humpback whale is migrating north from Hawaii to Alaska. But why they're migrating? Why humpback whale is migrating north to Alaska? The answer is here. If I overlay the scientific data of the plankton blooming, it's a photosynthetic planktons blooming from spring during summer, then it becomes understandable. They migrate north in order to feed themselves. You can see how abundant the plankton is in the Bering Sea and the Okhotsk Sea. And this is the representation of the abundance of our living planet, the primary production, the basis of the food chain. But it also represents the very well-tuned carbon cycle. After Toyako's GH Summit and the COP15 in Copenhagen, it is becoming a consensus that we need to halve our CO2 emission by 2050. But why halve? Why halve? Because the ocean and forest are absorbing the CO2 in the atmosphere. Almost half of our emitted CO2 is absorbed in ocean and forest. And the main actor of the absorbing CO2 is this photosynthetic plankton in the ocean and the forest in Siberia or Amazon. So this is a representation of the food chain and also the carbon cycle, representing the abundance of our planet. And if you look at Atlantic Sea, you will see another interesting example of a migratory birds. It's an Arctic terns, which is migrating south all the way to Antarctic continent from Greenland. Can you imagine this? I'll replay the trace of Arctic terns. This data is provided from the researcher in Greenland Institute, because this globe is already installed in Copenhagen, and the curator of the Copenhagen Science Museum introduced me to the researcher of Greenland. And this data is shown on this globe. with the plankton blooming data, which is provided from the researcher in Hokkaido University. So only on this platform, the diverse scientific data from the diverse field is combined and synthesized. That's why I call this instrument a kind of the Earth synthesizer, to synthesize the various data from the scientific data like this. And so even the researcher of the migratory birds said that this was the first time for him to look at the trace of migratory birds dynamically with the data of the plankton blooming. And if you look at the trace of the two birds, they are moving, hanging around the most abundant area of the blooming. Even researchers are so surprised to see that they're always hanging around these abundant areas. So this kind of visualization is a very gift in our generation. We are the first generation who have the freedom to look at our dynamic globe in this way. So that is why somebody should do this kind of work. It's a self-recognition of our planet and self-recognition of ourselves, maybe. There's another interesting example in Pacific areas. It's a migration of bluefin tuna starting from California. I don't know they are husband and wife. But each tuna has their own preference, actually. Now here is another representation of the carbon cycle. It's a Siberian area, just like a breathing of our planet. It gets blue and yellow, blue and yellow. It is because in springtime, the forest in Siberia absorb more CO2, so the concentration of the atmosphere decreases. And in wintertime, it increases. So it results in such a zigzag patterns. And this zigzag pattern is also represented on this globe. So it's absorbing and but sorry, here's a time bar indicating the time, and it's showing you the CO2 concentration variation of the last 20 years. And seasonal, in terms of the seasonal variation, it becomes blue and yellow, with a zigzag pattern. But over the 20 years, it becomes more red, and there's no blue part, because basically the CO2 concentration is increasing over the last 20 years because we are emitting the double amount of the CO2, double of the capacity of the CO2 absorption by ocean and forest. That's why we are the CO2 concentration is increasing, and we are surely changing the composition of the atmosphere. So that result in the global warming. This is the representation of the simulated data about the progression of the global warming in this century based on the IPCC's A1B scenario, emission scenario. So in this scenario, it is shown that if we continue our lifestyle in this way, consuming more fossil fuels, and our projected future is like this. And red color represents the temperature rise by 3 degrees, and the yellow represents the more 3 degrees. And that means there's 6 degrees temperature rise. And I stopped at 2050, and you can see the yellow part is in the Arctic areas and also the Tibet Himalaya area. So you can see some areas is more vulnerable, and some areas represent more rapid temperature rise than the rest of the world. And the reason why the temperature is rising rapidly in these areas, such as Arctic Sea and the Himalaya Tibet areas, is that these areas are covered with snow and ice, just like wearing the white t-shirt. And so the white t-shirts reflect the sunlight at the first stage, but if the ice shrinks or diminishes due to the warming, then the white shirt turns into the black shirts, and they start absorbing more heat. So that accelerates the warming process, so-called the positive feedback. And these areas are, we can easily understand that these areas are especially vulnerable to the global warming. And actually the symptoms is very clear in this area. Arctic Sea without ice, or the glacier melts in Greenland. And if you proceed to Alps, you'll see the image of the glacier melts. These white area is not the snow or ice, but it's a sheet which is covering the small amount of glaciers. They are trying to protect the ice, but this is a desperate trial. And if you move on to the Himalayas, this is the difference in 20 years before, after, the 1978 and 1998. So the glacier is diminishing in such a rapid and maybe the Tibet and Himalaya is very far away from the people in the United States, even for the people in Japan. And the Japanese people never thought of the influence of the glacier melt in Himalaya on their own life. But actually, it influences a lot, because this is the source of all big rivers in Asian countries, like Yellow Rivers and Yangtze River, Mekong, Ganges, and Indus. Every rivers has a source on this glacier. So it's a bank of the water. And if this glacier diminishes, the result will be like this. This is the Yellow River, image of the Yellow River, but nowadays it's drying up like this mainly because of the shrink of the water reserves in the Himalayas. So it results in the lack of water and water shortages. Causes due to the water shortages, many farmers stop the cultivating, and the food production reduces in China, and the demand and supply of the grains and food is fluctuating a lot. So global warming causes the water shortage and food shortage in this way. So we can understand we are facing the big challenge. But at the same time, I always think that the fact that we are recognizing this kind of the change is itself a great thing. I always think that on the scale of the Earth, we humans are a tiny existence, like the say fleas on the back of the huge elephant. But this flea start sensing and monitoring the subtle change of the physical condition and the body temperature of the host elephant, and start talking about the global warming or climate change. So this simulated data, it's a simulation of the global warming progression in this century. But this globe represents not only the present and the future of our planet, but also it represents the present situation of the human intelligence, how we are recognizing our own planet, our host. I created this globe not only as a mere digital globe, but also something which represents our own situation. And this is the globe is now showing the air pollutant, global circulation of the air pollutant. And you can see some poisonous gases are emitted from certain countries and they are flowing over the globe. But the point here is that if you look at our globe in this angle, you can see we are so connected to each other. And any contamination from any country causes a global contamination. Blue represents the SO2, green NO2, and nitrogen dioxide or sulfur dioxide. But anyway, we are connected to each other in sharing one globe. So more than maybe 50 years ago, the Buckminster Fuller proposed the idea that there should be a computerized digital globe which represents the present situation of our planet in front of the UN building to update the decision-making process of the world politics. But now I think this kind of idea could be realized. And we do need this kind of the self-monitoring system to adapt ourselves to the global situation, global lifestyle. we do influence the whole globe through our lifestyle, and but actually we can sense and monitor what is really going on our planet. So my vision is that this kind of globe should be installed in every school at least, and we are creating the smaller size of this kind of things, and so that kind of thing should be installed in every houses. At the last part of this talk, I can show you the image of the smaller version also. But anyway, I think it's a high time to disseminate this kind of global media to share the idea that we are living on such a beautiful and dynamic planet, and we are influencing on the whole composition of our planet. But there is some alternative way to live with this beautiful living planet. Thank you very much.
Well, you know, I think it's pretty amazing to come from being an anthropologist, where I understood that you studied different kinds of people around the world, in every continent except, was it the Antarctic?
Yes.
And to become a media producer like this. Perhaps you could tell us how that happened and why that happened.
Well, I had one thing is that you hear me? Okay. I had a difficulty sharing my experience to even to my colleagues who was field working in different areas around the world, and at the same time we face actually we face the forest destruction or other contamination, the other environmental problems, which we need to cope with, and so the 19th century style anthropology research is no longer effective in any areas, and I try to propose some new way to serve for the global situation as an anthropologist, but it couldn't be done in the academic field actually. So I started working in the museums, the ethnological museums, and some of the other museums, and curating some of the events or exhibition. And through that kind of work, I collaborate with the designers or creators, IT programmers, and it was quite natural for me to organize the interdisciplinary team to create the new way to convey what is really going on our planet. And so this is my first trial to visualize our living planet. This is a part of the website called Sensorium. This is the first representation of the seismic events, almost in real time. We found the database, real-time database of the seismic events. So I happened to think of this kind of way to visualize the seismic data in the animation. But it was awarded the Golden Nika Prize in the Ars Electronica Festival. But I was not satisfied with the two-dimensional expression because I wanted to feel more about the living Earth in a more tangible way. And so this is the first trial, but actually from this work, I started my career as a media designer.
So I'm sure soon people from the audience want to ask questions, but you know, we are a design museum,
Yes.
And I'm fascinated by the design of the globe itself as a piece of media production. I mean, the whole, I've seen inside, so I know that there's a computer projector in the center there with a fisheye lens that's projecting this information onto the inside of this transparent or translucent surface, and that you've managed to make these touch-sensitive things around this rim or periphery, which allows that adjustability or interaction where you can steer it. But what I'm fascinated by is like how you came up with that. I mean, to move from the golf ball with pimples to something as great as this is a big step. So I'd love to know how you felt about that design. Was it you or your team together? I mean,
yeah, team
how did
together,
that really happen?
Course. Yeah.
What was the inspiration?
Yeah, actually, I needed some tangible things to understand the globe. So I ordered, my way is to talk about my own idea to the audience or to the interdisciplinary team or anywhere else. I keep on talking and talking about my idea. And one engineer who is versed in astronomy and planetarium, he coined the idea to take advantage of the mechanism of planetarium. It's a kind of the small planetarium in terms of the mechanism. The difference is that we are looking at the sphere from outside. In case of the planetarium, they are looking the sphere from inside. So the name Mr. Iwamasa, he is the one of the core member of our team. He suggested to make this kind of hemisphere projector system, taking advantage of the structure of the planetarium. But it took more than 5 years to adjust the sensor system in this way, because it's a process of try and error. So now it becomes like this, and even children can spin it like this very easily. But it's not like that when we released our prototype in 2002. So after 3 years from the prototype, around 2005, we have reached maybe what we call version 1.0. Yeah. But still, it's in the infant stage.
And I understand that even this afternoon, it was spinning a little bit on its own. It just, it had a bit of a mind of its own. It started to need some adjustment. But luckily, your wife was here, and she realized that there was a screw that was tightened a little bit too tight on the ring, which was causing the pressure sensor to always be operated. So the thing was spinning on its own. So even now, it needs some looking after and care for.
As you said, she's making a directable dinner, yeah. Maybe she's far better than me in terms of this kind of things. Yeah.
I think the other thing that's incredible about this is that there is so much rigor in the data. I mean, if you look at all these demonstrations where you're taking the ocean currents or the migration or the global warming, all of that information is collated and connected to form this single synthesis from all sorts of different sources. So the rigor with which that scientific data is collected and curated and synthesized to produce a single result, that's something that's really powerful about it. And you must have been in touch with many scientific organizations too.
Of course. It's a kind of win-win relationship. I asked the researcher to provide their very precious data, but if we overlay his data or her data with other kind of data, there is always be a big discovery, even for researchers. So that's why I call it the Earth synthesizer. there's no platform like this to synthesize the various data, scientific data, and also even for researchers, it's a rare opportunity to see their own data in their spheres in a dynamic animation. So even for the researchers, it's time to create this kind of the platform to exchange the data among themselves. And yes, and also through the occasion like COP10 or COP15 or other international conference, we extend the networks. And nowadays, this globe is located in Copenhagen, Amsterdam, and Doha in Middle East. And hopefully, not only in New York. New York is the first place in the American continent. Yes. And hopefully, in next February, to Cape Town in South Africa, where we met for the first time. So through this kind of the extension of our network, we are creating the contents in the style like the global Wikipedia. So we are really enjoying this kind of the compilation.
Why don't we have a couple of questions now then, and we can come back to the baby globe. Here's one over here.
I'm very interested in the technology that underpins your work. Certainly the results are fabulous, but it'd be interesting to understand what's behind the curtain. I understand the planetarium issue, but I have 3 questions. Is the data being processed and calculated on the fly, or is this playback of a recording? If I had a data set that I wanted to install, is there a format for that data set and an API so that I can easily plug into this and use the existing data sets contributed by other people? And then what are the hardware requirements to build the models today?
Thank you. Actually, we have established our own CMS, Contents Management System, online, so through which you can put your own data. Okay. But it depends on the data. For example, this kind of the animation of the global data, it's sometimes is the big load for the computer. So we have to trim, we have to adjust the data size. But in the most case, you can put your own data through your PC through the internet on our server, and you can share your own data with all the partners, which has its globe. And we are creating a smaller version, but the smaller version is basically with the diameter of the 40 centimeters or something. So it's not good for exhibition or the demonstration in front of the audience. But if it's used in the schools or among the several pupils or students, that will be nice.
There's one down here.
I'm just wondering, what's the most expensive part of this?
Part. Actually, it's not so magical as it seems. It's composed of the projector normal. Yeah. It's composed of the normal projector. With a fisheye lens. Maybe the fisheye lens is a kind of special things, but anyway, it's not too expensive. And it's composed of the 2 normal PC, the Windows PC, So the most expensive part is maybe the fabrication. And also the main part of the value of this globe is the contents and how the contents are shown and how contents are compiled in the certain stories. So in terms of the hardware, the composition is the normal things, actually. So from this original work, I got the three visions: the designing a public-centric platform of the global age, visualization of the whole globe, and the second is the creating a senseware to let us feel connected to the other side of the globe or something. And the third is the kind of the what I call the jigsaw puzzle model. And first we created the tangible Earth, and the second point is that we have created the senseware to broaden the bandwidth of our imagination. So one of the examples is the Aquascape, the global stethoscope project, which enables us to listen to the real-time sound. And the concept of this project is the online presence and context awareness. And also we organized the team to maintain the constant communication with the children in Afghanistan, Sri Lanka, and some other countries in the south in Global Expo in 2005, because it's an experimental project to connect our daily life with each other. And let me introduce one example of our senseware. Have I told you something about the water exhibition? Water exhibition is is held in Tokyo Roppongi in 2008 in the 2121 design site in Roppongi, where I curated the whole exhibition on water with the famous creative director Taku Sato. And this is the exhibition on the water. And I created the water exhibition. And one of the items are exhibited in Cooper-Hewitt, Furumai. But one thing I want to show you here is that this is the senseware using tap water, because this is the actual water tap in the toilet is taken advantage of as one of the exhibition piece here. If you place your hand under the water tap, the water is poured on your hand and the image will be projected on the water. And the projected image is the real-time image of the source, water source, actually. So you can see where your water is coming from, and if there is a real-time sound, you can listen to the bird song or something, so that you can extend your imagination about your water use. And everybody is somebody's downstream and somebody's upstream. So that kind of relationship is now not visible in the urban daily life, but we wanted to visualize this kind of potential relationship.
I think I'm definitely your downstream. And I also know that I'm a flea and an elephant, but so are you. So I think we have time just for one more question.
Okay, yes, please.
So would somebody else like to bring up a point, make a comment? I see a couple of hands there. Maybe we could do two.
Hello. I was just wondering about all this information and data and how the internet is sort of bringing us all together in this modern age, and how your data visualization could be perhaps open sourced in maybe, how Google has sort of taken, and how Google Maps basically allows us to go anywhere in the world these days and sort of get that information out into the world, and how you see that.
Thank you very much. What I was planning to show you is exactly the answer for this question, maybe. So let me demonstrate one thing. This is one of our project called Sakurascape, one of the project of the syn-active platform design. This is their website visualizing the sakura cherry blossom front in Japan, and I'm now replaying the animation of the cherry blossom front moving up north according to the season from the April until January. You can see the sakura cherry blossom is blooming from south to north. But the point here is that this is representing the each post from the cell phones of the people living around Japan. So for example, and they are posting their photos of cherry blossoms and the message with haiku, 70-syllable poems. So what I wanted to do this here is that, okay, I show you the example of the compiling the scientific data from the researchers and showing it on the globe. But this social experiment is to compile the daily experience of the people, not only the scientists. There are lots of fleas on Japanese archipelago feeding the seasonal change by cherry blossom blooming. So they feel, in many ways, the cherry blossom blooming and the spring season. So we collected their experiential resources, their memories and their feelings through cell phones. And this is what I call the jigsaw puzzle process. This is one of the examples of the what I'm thinking.
And that's open source, okay?
At the last message, I will show you the video of the smaller version.
Okay, good.
Okay? Yeah. So it's a small hemisphere surrounded by the tabletop, and some message, real-time message, and some posts are projected from the projector at the ceiling. And so you can sit on the table surrounding the living globe. And in this version, we are trying the new ways to show some data like this. The image are directly projected on the hemisphere. In this version, I chose not to do it because it should be, I wanted this globe to be seen as a living globe. So without showing any artificial materials. But in the smaller version, I'm trying this kind of way of representing the various images on the globe So magnifying function works in this way. If you bring some dots or thumbnails into the magnifying zone, you can extend the image or the animation starts. And if you bring the North Pole at the top, then you can get the whole image about these each areas are located and each photos are representing the 2 hours difference. So half of the images are representing the image in the daylight, and the another half representing the shade areas, night. Okay, so thank you for extending the session.